My name is Nelson William. I have two names, one from my mother and one from my father. And I'm principal security researcher at Palo Alto Networks. I work specifically tracking cloud threat actors. This presentation is about cloud threat actors, but specifically using containers for doing malicious activities. I'm assuming that everybody is familiar with containers, and during the presentation you will see some slides with source code. You don't have to understand the source code. I'm going to explain what is the idea. And we are going to cover, regarding to containers, we are going to cover different aspects of that. So we are going to analyze the context where containers are executed by threat actor. We are going to analyze the different scenario where the threat actor are using containers. Then we are going to display or analyze one specific campaign, which is very interesting. That campaign is only using containers for deploying the full activity. And then we are going to look at the different mistakes that threat actors are using when they're using containers. These mistakes are because one reason. So in the past, normally in the traditional compromise chain, you have somebody that click one link, right? Click a link, you get a compromise for some vulnerability, and you download one binary or a group of binary. The difference with that, containers is the whole environment. It's not one binary. So you have a whole environment like a mini operating system environment. That is very good for the researcher point of view, because the attacker make many mistakes when they try to use that full environment to deploy malicious artifacts. One of the things that we are going to look as well is in the, we are going to talk about specifically about the Purple Urchin campaign. I don't know if you are familiar with that. And we are going to analyze in that campaign all the possible mistakes that the attacker made. And then we finally, we will put an example of how those mistakes lead to the geolocations, exact geolocations, and names of the, and the name used for that, that actor. I don't know, is any Crystal Holloway in the audience? I don't have a face for this guy yet. I'm just fishing for a face, trying to find a face yet. And you will see at the end of the presentation how this alias was used for one technique that we named play and run with in cloud activity. So it's going to be very, very interesting. So let's go to talk about quickly about the context. That is the X cloud model that we know today. I will see when you move from the left to the right, you will find how the different layer in the stack is being managed for somebody else. And you are, as a client, as a customer of the cloud model, you just use the layers that are green in this case. This is very important. This is very important to recognize this. Why? Because the area that you don't manage is where the security is shared, the responsibility of the security is shared between you and somebody else. And another interesting thing is sometimes you are a customer of the company, and the company is already run over some cloud provider, meaning that the shared responsibility is expanding to different parties. And some planes you may have, if you take in consideration that those parts also have external contractors, you will see that you don't know, you're using a cloud service, and you don't know that you have been depending on many people, that your security has to be protected by many people, so you are going to be affected by that without knowing it. We are living very interesting time because this problem is not solved. The problem of shared responsibility is not solved yet. In the case of container, we can see that The threat actor that we are going to talk about today, it moves specifically in the area, they can run containers, or we can run source code. We are going to talk about containers, but the threat actor that we were monitoring also use source code. When you, so this is a serverless, normally it's known as a serverless services. They just load the source code and the source code run there, right? And in the case, what we are going to see here is the way that they use containers in this environment. So this is one general example of the service that the threat actor was using across different cloud providers, of different mechanisms that they were using. So in Azure, he used normally create. In Clever Cloud, he used Clever Create Docker. In Evernote, he used Evernote as well. So this is just an example to get one idea, but the number of different cloud providers the threat actor use was like a 50, around 50. I just take the most known cloud provider here. And you will see interesting like GitHub, which is not per se cloud provider, but it has a mechanisms, which is known as workflows to execute container. We are going to see how he was be able to use GitHub to scale the whole operation that he was doing. And Heroku was another target. So we know this threat actor because we have requests from Heroku at the beginning, and then we continue the search, and then we follow up with that threat actor, and we cover more details. This is one example of how containers can be used today, even in, this is public, this is free, you can use right now in Colac Notebooks. So you can create your own container. I actually have a command that says shell. You can create a shell in the notebooks. And in the notebooks, you can embed the script, you can build the whole container, and you can run your container. This is very known functionality, and this is putting one example how do you run containers in free services. Now, containers have been evolved very fast. Actually, evolves practically the driving force for DevOps. And it makes a good change in the mentality how we deploy software. That is why containers are very important. But we have many years around, many years of container development right now. And because of that, we have bad things related to container being accumulated in different areas. We are going to see a sample of that. So we have container scams. You will see what are the scams. We have containers everywhere. We have traces of containers, malicious containers, which is still there. We are still alive, but they exist there. And we have containers with bad things, which usually implies that the container contains malware, for example. So this is, this example is very fun because normally what people know is that in Docker Hub, you have malicious containers. And a recent publication showed that 20% of the containers in Docker Hub contain malicious binary. But this example is very funny because this is a threat actor using Docker Hub as a phishing website. So if you go right now to Docker Hub, you type Viagra. Of course, Viagra is the most known word for phishing, for spam. You type that, you will see many accounts. This is just one example. You see many, hundreds, probably thousands of accounts that use the Docker Hub website as a spam. So what you find is they have some text, they have a link. In many of them, if you follow the link, you get compromised with malware. We have, in our team, we have a honeypot monitoring cloud activity. And that honeypot is specifically designed for cloud. It's very native for cloud, use only cloud technology. And one of the things that allows that Honey Cloud is to execute containers. And we track how the attacker are using containers when you have a free way to execute those containers. And you will see they get very smart. They still, I don't know if you're familiar with the concept fileless execution, but here what you will see is fileless containers, meaning that they are executing the operation in container without using a malicious container. Just use a normal container, which you see Alpine is the name of the container, and Ubuntu is another name of the container, but they use a command line in the entry point of the container to run, in this case, they are communicating with the TNC to download for the sample. And this is an example of a fileless entry point when you use a container with non-malicious container, but just doing malicious activity with that. This is another example of the ransomware using interested in encrypting and deleting container. I don't know why they do that, because in reality containers are very dynamic and you not depend too much on container. Now maybe the container has some mount data that is very important, and they were encrypting, in this case, container artifacts. Another example is this is very known, the cryptofile over containers, where if you are tracking operation of different groups, they start deleting the container created by another group. And this is an example where one group, in the case of Watchdog group, was deleting existing container from another group that the other group also deployed container for doing this activity. This is very important because we have a lot of cases in leaks credentials. And this is real leaks that we can find in internet. Leaking Docker Compose file with user variable, with environment variable, having values which are very critical, which contain password, contain credentials, contains information about the infrastructure of the customer. I deleted all the important information here. This is container malicious trails. So you can find that today in Docker. So this is trails of previous campaign of using malicious container, which are still there. There are hundreds of them in Docker Hub. This is a real attack, how the threat actor that we are going to talk about in the few slides coming was using Google Colab notebook to execute containers. Just recur to one URL. That URL has a script, and that script will create the container and will execute the container there. Before going forward, let's talk about a little bit more about the structure of the container, how the containers work in general. It is important to understand the mistake that the attacker did in the campaign that we are going to talk about. So normally, when you have a container, what you do is you pull the container, you pull one known image, you input another Docker file, you create a Docker container, you push the container, you play with the container, maybe you run the container, you do something on the container, you commit the container, you can commit the container, meaning that the container, if you have any change, you save the change, and then you push the change of the container change again. This is the cycle of the container. Now you see, during the container life cycle, there is many new point of artifacts, of forensic artifacts, that you can use to track the threat actor. In the past, for example, when you have a binary, it's very normal that threat actor modify the creation time of the binary. They play with the creation time of the binary, so you don't know when the binary was compiled and when the binary was started to be used. In the case when you are creating malicious Docker containers, it's super difficult because there is metadata associated with the repo that you cannot change. And there is metadata associated with the container that is not easy to change, at least that you change the Docker engine by itself. So this is another kind of operation that you do on container when you are working with container. You normally do a container run to run the container. If you go inside the container and you touch a file, you create the file inside the container, and then suppose that you did that operation, then the operation tree, you create a tag for the container, and you push the tag, you save the container. In this case, in the first line, that operation, tag and push, it has a persistent local change. When you do the touch file, you have a change local, but when you push the container, the change to the touch file is not persistent remotely. Meaning that the meaning of this is, if you are a threat researcher and you find a container which is malicious, if you download the container to analyze to serve the container, meaning that the local persistence of the change of the touch file, it was lost. But if you, for some reason, play with the container and you commit the container, then you have a local persistence, but when you push the container right now, then you have remote persistence. And when you have remote persistence, you have the change that the threat actor did to that container. So this is very dangerous operation that you, as a malicious actor, should be doing. Knowing that, there is we are going to talk about a couple of mistakes, and that the threat actor may do when they use a container. As I said before, container are complex artifacts. It's not a binary. It's almost practically operating system that you build, a small operating system that you build, you deploy. Operating system, in a way, they have a file system, it has more artifacts, but it's not a binary. It's a whole system inside. So we will see different mistakes. We are going to see how this mistake translate in the purple-roaching operation. So we have entry point, we have Docker ingress timing. We are going to show that. Docker command history is very important. Hard code credentials, and the one that I just mentioned, which is a pull, commit, push, when you are playing with containers. So right now we are going to talk a little bit more about the purple-roaching campaign. The purple-roaching campaign was, so SysDig was the first one to publish that. We were working on that already, and then we collected all the data that we already have, and then we published it with that. We were able to collect more than 300 gigabytes of data, just containers, just in form of containers. 50 gigabytes of infrastructure, so we will be able to access the infrastructure of the attacker. We collected 50 gigabytes there. We collected more than 40 crypto wallets. The attacker, the whole thing used like 30 different platform providers. He will be able to create 23,000 GitHub accounts and more than 100,000 Heroku accounts. So we are going to see how he created so many GitHub accounts. This is the architecture. So the architecture is very well split, but every operation, every part in the architecture is implemented with containers. So the player run a scenario, is going to explain later. It's a mechanism, it's a way that he approached the way to use or to create containers which are deployed later to other places. And the free hacking operation is, the free hacking part is the mechanisms that he used for creating an account in those systems. And once he was able to create an account in those systems, automatically he started pushing containers to those systems. Finally, he managed to have different crypto exchange. We identify around 30 crypto exchange. They just a few one there. And they use proxy as well to, we are going to see the example of how they use the proxy. So this is a statistic about the number of Docker Hub accounts that he created, 143, 130. So there is a bunch of GitHub accounts that he created, and we will be able to recover 300 containers. So it's that mentioned the amount of gigabytes, 30 gigabytes that we were able to recover just in form of container. This map is reveals not only, this map is not where the containers connected with. This map is where the container actually were executed. So because we will be able to access infrastructure data from the attacker infrastructure, we will be able to map where the different containers were actually being executed. So those containers were executed in different cloud providers, in different in some free hacking services like GitHub, we are going to show. But we'll be able to track where those containers actually run. Now we are going to talk about the GitHub operation. So the GitHub operation that he implementing is very interesting because the challenge that he has was to create as much as possible GitHub accounts. For Latest, with that GitHub account, what they had is they have to use workflow to execute the containers automatically. And he used this mechanism. This this section that you see in the left side is a container. So that section is a container. So we have basically in the container he used XDO tool to automate the browser, and he used one extension for two things. One thing is for implementing proxy in the extension, the browser extension, and another thing is for blocking himself from being tracked. That mechanism was implemented in a container. This was the technique that we were using for bypassing the GitHub CAPTCHA. After we reported this, the CAPTCHA was the CAPTCHA was changed. The mechanism was very simple. The only thing that he has to do in this case, in this kind of CAPTCHA, was identifying what is the spiral galaxy. And what he did was with just one command line, two command lines. He just converted the original image to red, green, blue, and then he calculated the queuing of the red channel. And the value is the smaller value is the galaxy. So in this case, you will see 0.932. In this case, is the second one is spiral galaxy. Just with few command lines, he was able to bypass the CAPTCHA mechanism implemented GitHub at the time of we were working with this. Using that mechanism that you see, he was able to create more than 22,000 GitHub accounts. But the interesting thing is not how many accounts he created. The interesting thing is how many executions he was able to achieve with those accounts. He was able to achieve more than 1 million container execution using workflows. This workflow, each workflow has 64 jobs. So he created in the same container, he created the workflow, have a template, the workflow, and each template has 64 jobs. But how do we know that number? Because normally you don't know what is being executed, right? So we will be able to access the infrastructure of the attacker, and we map the successful executions. And we counted that with that correlated data. We analyzed the container, we correlated the information from the container plus the infrastructure data, and it gives you that number, exactly that number, how many successful executions he was able to achieve using workflow. So now let's see what kind of mistake he made in this whole operation, because he was using containers. Normally, you can find many artifacts in container. We will see a couple of them. One of the most interesting one is that you have application debugging logs, you have application access logs. The access log, normally when you are reviewing the access log, when you are analyzing access log, you divide the access log in access by external tool, because when you open port, so he has the container running, but he has to open a port to monitor a panel, actually a panel that he has in each container. And when you do that, you receive a lot of automatic boot access to that panel, and that access are automatic tools. That is not important from the point of view of forensic by itself. You have access by the same infrastructure operation, meaning that you have access coming from other containers which are managed in the container, and the interesting one is you have access by the threat actor that he did from manual operations. At the end of the day, he has a panel, and he wants to access the panel. If he makes a mistake accessing the panel from one of the IP that he's using, we know where that's coming from. This actor specifically, he was very, he has a lot of expertise in developing container and developing software, but he didn't have too much expertise covering his tracks. You will see. So we found normally containers, when you create a container, you download an initial container, you create a new container from that container, the number of layers in the operating system, you will have a layer for exchange that is made to the container, and this is reflected in the operating system. So we found one container with 98 layers of file versions, you can say, in the file system. Even there is one public tool that is named Dive tool that was very slow. We couldn't work with that tool, so we created our own tool for doing the forensic analysis of these 98 layers. This is a sample of the commit mistake. So he basically, one of the things that happened is he was creating a container from inside a container. And the external container, which also he working with, he commit that container as well. I don't know why he committed that container. It was local only needed, but he committed that mistake after he made a lot of change in the infrastructure. And you will see this command as coming from the bash history of the container that he was using to create another container, which he, at the same time, he committed as a container to the Docker repo. And you will see how different log example as well that was committed to the container. When the container was pushed, was already in the file system, and the file system, that change is persistent, and you will see that in the remote data. This is a lot of this. Even the database that he was working on the operation, this is internal database that we pull out from the container, also was there completely accessible to us. So these contain usernames, this contain username, contain crypto wallets, contains where the crypto wallet was assigned to, what exchange, to what pool was assigned to be working with. A lot of data from inside. Another thing that we were interested in is to know from when this attacker was started to work with. And we tracked with the passive DNS data, we easily tracked to 2021, to 2021 to 2023. But we noticed that one container was created into, two containers were created in 2017. But what happened is those containers, when you push a container to a Docker repo, the creation time, the tag time is not preserved, but the creation time is preserved. So if you you create a container from another container that was created before you, that creation time is not the same that the time that he created the container. And for that reason, this was like a false positive for this year, so we could identify this year. What we found later was that the Docker repo showed that container specifically was in 2022, so it wasn't this entry point was in 2017, but was that because it was a previous tag, a previous container that he was building from. But we were able to find one certificate, and that certificate was from 2020, so 1 year back, 2020. And then we found activity, we found source code inside the container that was using all Docker API. And the Docker API expired, that Docker API wasn't in service anymore in 2019. So at the end of the day, we conclude that, that this operation started in 2019 to 2023. This is another template mistake that he made. And when you do Docker expose, if you declare the port during the container creation, it's easily for you to estimate, to scan internet, so to look for further scanning internet to look for those ports, or for the behavior on those ports to identify further containers that may be running in in other scenarios. This is another way to be exposed himself. Another mistake that he made a lot of command lines using infrastructure, IP related to infrastructure, domains name that is very used also as well in the command line. So with that, we grab a lot of interesting information to track him down. Another very bad mistake that he made was hardcore credential inside the container. So a lot of configuration in the infrastructure. The infrastructure was big, and he used hardcode credentials in many configuration files that were pushed to the Docker hub inside the container by itself. When you get the container, you start the information, you get a lot of data like this one. So we were able to find hardcode credentials. One of the interesting things that we found is in one of the committed containers to the Docker repo was one access. It has a huge amount of log of information, but we found one panel access from one very interesting IP, and that IP was the first one that we found to know the location of him. So if you see, there is a lot of logs, but only one access. So there is a panel. He created a panel in one of the containers to track how the operation was, the mining operation was growing up over the time. We reconstructed the panel as well to know what he was looking at. But that access to that was a huge mistake by him, but not only mistake. He made two mistakes. One mistake was accessing the panel with that IP, and the second one was committing the container to the Docker repo after he made the access with the access got registered in the container content by itself. And then that IP usually lead us to Cape Town, and this is a mobile access clearing. So if you use routing glasses, routers, looking glass router, you will see that the nomenclature of the reverse DNS of the IP, it tells you what is the service, the type of service that the IP we're using at that moment. In this case, it was clear that was access from the phone. This case, for this IP. So this panel, in this case, it was access from the phone. So he has all the operation running and was checking with the phone how it's going the operation. And this led us, later with further investigation, we found another interesting IP. And once we accessed the infrastructure, we were able to identify the cell phone that he was, the cell phone model that he was using during the panel access. We will be able to identify another IP, which is also both IP, they lead you to the same home. So we have, and this IP, this new IP is a computer IP. It's a service provider IP. It's not a phone IP. So both the phone IP plus the normal IP, the service provider provide you to your home, is locating the threat in the same place. And we take a little bit look more to the IP, and we found there is a torrent server in the machine open for he was using it. So in other words, in the home computer, he was using torrent as well for other stuff. And digging further a little bit more, we found the alias, Christo Holloway. That's the alias that he used to run the whole operation. You will see more interesting stuff about that name now. So that is data about the second IP. So this is the home provider in Cape Town. This is information related to that correlate to the second IP. This is play and run indicator. So because we were able to access the infrastructure, we were able to identify that he was creating fake accounts in different cloud providers, but he didn't pay the bill. So he just created the account, play with the thing that he was doing, deploying the infrastructure, and he then it run away. He didn't pay anything. So we found one account. So in the majority of them, we didn't find how much the debt, but one we were able to identify that he was a debt of 50 euros. And because of this, we were able to identify, I anonymized that, but we were able to identify the exact address that if we're using correlated to that fake account. And this, all the data collected and correlated point out to that, exactly to that location. Later, as we continued the investigation, we found one LinkedIn account that is named Linux, that it corresponds with the username that we use inside the containers. And the Linux account is co-located in Cape Town. He is an experienced self-employed developer. During this operation, so he used different and various crypto tactics to not being tracked in a way that the wallets weren't being used. One of the tactics that we found are mentioned there. So was a very small value account in crypto system that you do not accumulate too much money, so you don't know exactly how much money I'm doing with this operation. And another thing that he did very quickly, not only quickly, also automatically, he was changing in crypto change. He was changing the cryptocurrency for different cross different crypto change automatically. That was implemented automatically. And also we found that rapid movement balances intra-accounts in the same crypto change, but it moved the money from here to here, from this wallet to this wallet. Another interesting thing that we use is multiple levels of agglomeration of wallets. So you have a wallet that is very small, another wallet that is very small, another wallet that is very small, and then you accumulate to another wallet, and then you accumulate a bunch of wallets, and then you accumulate to another wallet. That is another mechanism that he used to mask how much he was doing. So what to do with this? So containers, the attacker won't stop using containers. We took this example to give this presentation because the amount of design time he put there to create containers, and also show that the mistake that they make, so you can learn from the mistake that they made. But most important than that is to monitor your container living spaces, wherever you have container, know where a container running in your company. Discover unattended containers. Sometimes you left container there running forever. And know very well that supply chain attacks are difficult to detect, but in containers, if they are inside the container, they are even more difficult to detect. And monitor, of course, monitor all the containers executions that you have in your company, in any of the places that you may think of. Have a very clear view of all the containers are being run. Takeaways, containers are omnipresent today, and threat actors abuse container in many ways. So in this case, we took this example, but we have many more samples. We have actually national state threat actor using containers. This year, we published a campaign actually using a set of SSH proxies using forwarding, and was one multi-layer forwarding proxy of SSH servers implemented with container across different cloud providers, and all the objective of that change, the only objective of that is to reach the victim, which was already compromised. So containers are being used even for national state, even when we don't see that too much in the media yet. Containers are complex inside. Look, what is good for researchers and the threat actor have to manage that very well. We will see, the operation that we have, you will see over time more complex architectures using containers for doing malicious activity. And well, keep happy hunting for containers wherever you can find. Thank you very much. I think it's time for questions.
Hi. I'm new to containers, so this question may be very old. Are there steps available or are methods being constructed to avoid embedded credentials in containers?
So the first step, if you have container in your company, is to have credential scanning tools. Or there is a bunch of non-credential scanning tools that you can run, and those tools support containers. So normally you point that tools to container repos. So normally your containers, when you build a container, you push that container to a container repo, and then everybody use that container from there. You should be running credential detection, posting credential tools that detects in the files inside the container. They go inside the container, they extract the container, pull out the container, and they look through all the files inside the container for credentials. And that is the approach that is being followed today. So it's normally during your development cycle, you have credential scanning tools all over the place, even in your source code repo, in your container repo, all over the place in different part of the development cycle. You should have credential scanning tools to identify leaks.
So is there some kind of method to avoid that, what appears to me you're saying is a bad practice? Is that a bad practice or currently necessary practice?
Do you mean implementing a credential scanning tools?
No, putting credentials.
No, it's very bad practice in any place. Credential never has to be in any files. In plain text, they are the worst practice that you can have ever.
Okay.
And that should be identified early during development process. So normally, if you decide for some reason when you are developing that the credential should be in the file, that is the first time you will have to spot it, because this is a bad design from the beginning. And it's very important when you are architecturing your system to identify those bad practices, even from the beginning.
Okay, so it's not a necessary thing, which is, okay, thank you.
Should never ever be credentials in your archive, in your repository.
Well, right. I couldn't quite pick up from the presentation whether it was a necessary feature of containers unique from other kinds of code. So.
No.
Hacker has bad operational security.
Okay.
What about using Docker Scout for some type of remediation and for like static code analysis for checking things like this, etc.?
Yeah, exactly. Yes.
So
Thank you.
Opinion on Docker
Yeah,
Scout?
it's okay.
Okay.
Any other questions? Thank you.